Good morning, students. Welcome to the class of mathematics. Today we will take quickly one numerical based upon the movement of wheel. It's in rotational mechanics. Okay. The question based on rotational mechanics, right? So what is the rotation of wheels? That is on rotational mechanics. Okay. Students, we already learned in the laws of motion, A B equal to U plus AT, S equal to UT plus half AT square, and B square minus U square equal to 2S. So here we will just follow the same, but here the displacement, in place of displacement, it's an angular displacement. Here this is theta. Okay. And suppose the start from this point, the body starts moving. Okay. In this way, like this. Okay. And suppose this is the final position. Okay. So let's say B, and it starts from A. So when at A, the initial velocity is omega 0, and final, this is angular velocity. Yeah. And the final velocity is omega. Okay. So we know this in the same line length where we discussed about the initial laws of motions. So in rotational mechanics, we have theta equal to omega 0 t plus half alpha t square. Okay. What is alpha, students? Alpha is angular acceleration. Okay. Omega 0 is angular velocity at start, right? T is the time. And theta, what is theta? Theta is angular displacement, right? So students, we will just solve the questions based upon this. Here the wheel rotates with a constant acceleration of 2 radian per second square. Wheel starts from rest. So wheel starts from rest. So we can say wheel starts from rest. Okay, from rest. That means omega 0 is equal to 0, right? So here the first part omega 0 can be put as 0. So this will be 0. This is 0, right? And angular acceleration, you can see, is 2 radian per second square. So the value of alpha is 2, right? And time is given in, it's asking that how many revolutions will made in first 10 seconds. So time, so this is time equal to 10 seconds. So here t will be 10. So in the equation, given equation theta equal to omega 0 2 plus omega 0 t plus half alpha t square, time is given, angular acceleration is given, angular velocity at start is given, then we can easily calculate the angular displacement. So angular displacement will be omega 0 t plus half alpha t square, and putting the value will get 0 into 10 plus half into 2 into time square, means 10 square. Okay, the first term will be 0, and 2 will be cancelled out. Okay, here 2 will be cancelled out, and the value will be 100. So 100 radian is the value of theta. Okay, this is the value of theta which we are getting, that is angular displacement. Okay, now we are going to calculate the number of revolutions. Number of revolutions, how we'll calculate it? Number of revolutions will be equal to, when it will be divided by 2 pi. Okay, so we will write over here number of revolutions equal to theta by 2 pi, because in one cycle we complete 2 pi radian. Okay, so theta by 2 pi will be equal to, this will be equal to 100 by 2 pi. So when we calculate this, we'll get around 16 revolutions. So students, in this way we can solve such numericals based upon rotational mechanics. So we'll see up with some more questions going forward, and keep on learning. Happy learning. Subscribe to my channel. Bye bye.